Ravi was driving his car up a steep hill. Everything felt normal until suddenly the engine lost power. There was no warning, no smoke, just a sudden drop in performance. Confused, he took the car to a mechanic. He expected a serious engine problem. But the real issue was something much smaller, something most people have never even heard of. It was the exhaust gas temperature sensor, also known as the EGT sensor. Inside your engine, temperatures can rise beyond 800 degrees Celsius. That's hotter than molten metal. If this heat is not controlled, it can damage the turbocharger, exhaust valves, and even the engine itself. This is where the EGT sensor quietly does its job. It is placed directly in the exhaust system, constantly measuring how hot the gases are as they leave the engine. Every second, it sends this temperature data to the engine control unit, the brain of the car. Exhaust gas manifold and EGT sensor. The process begins in the engine's exhaust manifold, where hot exhaust gases from the engine's cylinders collect. The EGT sensor is strategically placed here to directly measure the temperature of these gases. The diagram shows the sensor immersed in the hot exhaust flow, highlighting its direct interaction with the heat. Temperature signal analog. As the EGT sensor detects the heat, it converts this thermal energy into an analog electrical signal. The strength or voltage of this analog signal is directly proportional to the temperature of the exhaust gases. Higher temperatures result in a stronger signal. Engine Control Unit (ECU) with ADC. This analog signal is then sent to the Engine Control Unit (ECU), which is the brain of the engine. Inside the ECU, there's an analog to digital converter (ADC). Since the ECU operates digitally, the ADC's role is to convert the incoming analog temperature signal into digital data that the ECU can process and understand. Digital data to ECU logic. Once converted to digital data, the temperature information is fed into the ECU's logic and protective strategies. The ECU is programmed with specific thresholds and responses based on exhaust gas temperatures. Real-time monitoring/diagnostics. The digital data from the EGT sensor is continuously monitored by the ECU for real-time performance tracking and diagnostics. This allows the system to identify potential issues as they arise. Protective strategies, conditional actions. If the ECU's logic determines that the exhaust gas temperature is exceeding a safe limit, it triggers protective strategies. These strategies are crucial for preventing damage to critical engine components. The diagram shows two primary actions: reduce engine net power/fuel injection timing. To lower the exhaust gas temperature, the ECU can adjust engine parameters. This often involves reducing the engine's net power output, making the car feel like it's losing power, as Ravi experienced, or altering the fuel injection timing. By optimizing combustion or reducing the amount of fuel, the ECU can bring down the temperature. Dashboard warning light. Simultaneously, if temperatures are too high or the sensor detects a fault, the ECU will illuminate a warning light on the dashboard. For example, a check engine light or a specific temperature warning to alert the driver to the problem. Think of it like a messenger, constantly informing the system about the heat level. When the temperature rises too much, the system reacts instantly. It reduces fuel injection, controls the turbo, and protects the engine from damage. In Ravi's case, the sensor had failed. Because of that, the system could not properly detect the rising heat. To prevent possible damage, the car automatically reduced power as a safety measure. What felt like a major engine failure was actually a small sensor doing its job in the background. Using on-board diagnostics, mechanics can easily identify such issues and monitor exhaust temperature in real time. In simple terms, the EGT sensor is like a thermometer, but for your engine's exhaust system. A tiny device hidden deep inside your car, silently protecting it every second. Now you know, sometimes the smallest parts play the biggest role. In summary, the EGT sensor acts as a vital guardian for the engine, constantly monitoring exhaust temperatures. When these temperatures become dangerously high, the sensor alerts the ECU, which then takes immediate protective measures to prevent severe and costly damage to components like the turbocharger, exhaust valves, and the engine itself. Follow for more simple and powerful automotive stories.